With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given? A particle of mass m charge q is moving in a region where uniform constant electric magnetic field E and B are present. Now E and B are parallel to each other, and at time t equal to 0, V naught is of the particle is perpendicular to E. Now we need to find the value of the velocity V of the particle at time t. Okay, in terms of t q m, V naught E B, and this B vector and the magnitudes of V naught E vector and B vector. Okay. Now, what is the situation? Let us just draw the coordinate and we just represent. This is our y, this is our x, and this is our z. Okay, this is our situation. So this is our x, this is our y, and this is our z. Okay. Now this this electric field is present in the y cap direction, and magnetic field is also present in the y cap direction. Now what we are doing? We are just projecting the particle in the x direction like this with the velocity v naught. Okay. So this is our v naught. We just represent this as to be our v naught, and this is our e vector, and this is our B vector, or we can say that this is the direction of the magnetic field, having a magnitude E electric field and B magnetic field. Okay. Now due to this electric field, there would be a force on this this charge. Okay, this is a positive charge. There would be a force in this direction. So what would be the acceleration in the y direction? So we say that acceleration in y direction would be equals to the force per unit mass. Now what would be the value of the force? Its charge is q, and electric field is E, so it would be q into E divided by the mass. Now there is no velocity initially, there is no velocity in the y direction. So at any time t, what would be the velocity in the y direction? Vy, basically we know that it is equal to uy plus ay into t, but there is no velocity in the y direction initially, so this term is 0. So it would be qe divided by m times t. Okay, what is the direction? This the direction is y, or we can say that y direction could be written as this. We can say that it is the basically j cap, and we can say that j cap would be equals to what? It would be E vector divided by the magnitude of E, and magnitude of electric field is given as to be E. This magnitude is E. This is not the vectors, but this is just E. So we can say that this is our j cap. So this is our Vy. Now similarly, what will happen? Now this velocity is perpendicular to B, this magnetic field. What will happen? So there would be a magnetic force which would be acting, which is given by V cross B. Okay, V cross B. Now what would be the direction of the V cross B? It is coming like this. So V cross B would be towards the, because this is in the x direction and magnetic field is in the y direction. So V cross B would turn out to be in the z direction. That means there would be a magnetic force in the z direction. Now due to this magnetic force, which is perpendicular to the velocity vector, it would be moving in a circle. Okay, moving in a circle, but there is also a velocity in the upward direction. So basically it will be moving in a circular path and a helical path. So the motion would be something like this. Okay, something like this. This would be the motion. Okay, now at any instant of time, so initially it is having a velocity, but magnetic field cannot change the value of this velocity. Okay, so let's assume that at any instant of time it is having a velocity v naught. Okay, and let's say it is this velocity is making an angle of, let's say from here the angle is theta, or we can say that this angle is theta, and theta would be equals to omega t. This is the v naught. Okay, now what would be the component of the velocity in the x direction? We can say that component would be v naught cos of omega t. And what would be the component of velocity in the z direction? This would be the z direction, so it would be equals to v naught sine of omega t. Now since it would be doing a circular motion in the magnetic field, so we can say that omega would be equals to what? Omega would be equals to qb divided by m. Okay, so our vx would become, so we just write our v vector would be vx I cap plus vy j cap plus vz k cap. Okay, now since we don't need to write the answer in terms of I, j, k cap, we need to write all the answer in terms of E vector, v naught vector, and b vector. So just rewrite this form. So our v vector would be equals to, what is the velocity vx? It is v naught cos omega t. Cos, what is the value of omega? qb divided by m into t. Now what would be our I cap? How can we define the direction of I cap? We see here. Now initially v naught is in the this I direction. V naught is in the this I cap direction or the x direction. So we can say that our I would be equals to vector v naught divided by the mod of the initial velocity, which is v naught. So we can say that our I would be equals to v naught vector divided by v naught. plus what is the velocity v y we have represented qet by m. So it is qe divided by m multiplied by t. Okay, this is e. We can just rewrite this. This is e. And what is the direction? J cap, we have already represented j cap to be e cap, e vector basically divided by mod of e. This is how we write the unit vectors. Now plus vz we have found v naught cos qb divided by m. Sorry, it is sine, not cos. We can just see here it is sine. In this it is sine omega t. So we just write this value has to be sine qb t divided by m. Okay, now we need to find what is the value of the k cap, because it would be in the k cap. Now what is the k cap direction? So initially what was the magnetic force? It was in the k cap direction. So we can say that our k cap would be equals to, so this vector v naught cross b, this vector, this would be in the k, this vector would be in the k direction. We can see, because this is I and this is j, so I cross j would be equals to k. Now if we divide it by the magnitude of this, okay, if we divide it by the magnitude, then it would be a unit vector. So we can just substitute the value of k vector as v naught cross b divided by mod of this value v naught cross b. So this is our final answer. Hope you have understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.